All right, today we're jumping into one of the most mysterious, most mind-bending, and honestly one of the coolest topics in the entire cosmos, black holes. And these things are way more than just science fiction. They're real, they are unbelievably powerful, and as you'll see, they're actually key to understanding how our universe works. So, let's just start with a simple question. What do you think is the ultimate trap in the universe? I'm not talking about some kind of cosmic spiderweb or an alien device. I mean a natural phenomenon so powerful that once you're in its grip, there is absolutely no way out. The answer, of course, is a black hole.
And here it is, the core idea. A black hole isn't an empty hole or some kind of portal. It's the total opposite. It's a staggering amount of matter, an incredible amount of stuff, all crushed down into a space that is impossibly, unbelievably tiny. That crazy concentration of mass creates a gravitational pull so extreme that nothing, not even light, the fastest thing in the universe, can get away.
So in this first part, we're going to break down what a black hole is actually made of, conceptually. We're going to define its key components and really get a gut feeling for how this ultimate gravity trap actually works. This is the classic way to picture it. Einstein taught us that massive objects literally bend the fabric of space and time. So think of the universe as this giant, stretched-out rubber sheet. A star, like our sun, is like a bowling ball making a little dip in the sheet, and planets orbit by just rolling along the curve of that dip. But a black hole? It's not just a dip. It's like taking a sharp needle and poking it all the way through the sheet, creating this infinitely deep well that, once you fall in, you can't climb out of. So what's at the very bottom of that well? It's this thing, the singularity. This is the heart of the black hole. It's the point where all the matter that made the black hole, an entire star, for instance, is crushed down into a point that is infinitely small and infinitely dense. And here's the really wild part. This is where our understanding of physics, of space and time as we know it, just completely breaks down. And surrounding that singularity is the famous event horizon. Now, this isn't a physical surface you could touch or knock on. It's an invisible boundary, a threshold in space. The second you cross it, the speed you'd need to get away, what we call escape velocity, becomes faster than the speed of light. And since nothing in the universe can travel faster than light, escape becomes physically impossible. It's the point of no return.
Here's a great way to think about it. Imagine you're in a boat on a river, and that river leads to a massive, powerful waterfall. Way upstream, you can paddle away, no problem. But you know there's a certain point where that current gets too strong, where it's moving faster than you can possibly paddle. Once you cross that invisible line, that's it. You're going over the edge no matter what. The event horizon is that invisible line for gravity.
So where do these cosmic monsters even come from? Well, their birth story is one of the most violent and spectacular events in the entire universe. It all starts with the life and the very dramatic death of a really, really massive star. Okay, so for millions, even billions of years, a massive star is in this perfect balancing act. You've got the nuclear fusion in its core, creating this huge outward pressure, pushing everything out, and that's constantly fighting the relentless inward crush of its own gravity. It's a cosmic tug-of-war. But eventually, that star runs out of fuel. The outward pressure just stops. And gravity wins. It wins big time. The core collapses violently, which triggers this unbelievable supernova explosion that can outshine an entire galaxy. And if that leftover core is still massive enough, we're talking about 3 times the mass of our sun, then nothing can stop its collapse. It just keeps crushing down and down and down until it forms a singularity. And just like that, a black hole is born.
Okay, so they're born from dead stars, and they trap light forever. But so what? Why should we care about these things that are so far away? Well, it turns out they aren't just destroyers. In a lot of ways, they're the universe's master architects.
First, let's just try to get a sense of scale here. Right at the center of our own galaxy, the Milky Way, there's a supermassive black hole. Its name is Sagittarius A star, and its mass is the same as 4 million of our suns. 4 million. And pretty much every other big galaxy out there has one of these behemoths at its heart.
So why does that matter? Well, for one, these supermassive black holes act like gravitational anchors, shaping how entire galaxies form and evolve over billions of years. They're also our most extreme physics labs. They let us test Einstein's theory of general relativity in conditions we could never, ever create on Earth. Every time we see light bending around one, or detect gravitational waves from 2 of them colliding, we're basically proving that Einstein was right. And ultimately, they might just hold the keys to a unified theory of everything that connects gravity to all the other forces of nature. All right, time for a little rapid-fire round. Because black holes are so mysterious, there's a lot of, well, misinformation out there, mostly from sci-fi. So let's tackle some of the most common questions and bust a few myths.
This is the big one, right? If they trap all light, how in the world do we even know they're there? Can you actually see one? And the short answer is no, not directly. But you can absolutely see the chaos they cause in the universe around them.
See, the key is that we detect them indirectly. We can see stars orbiting what looks like empty space at insane speeds. We can see the superheated gas that forms a glowing accretion disk as it spirals in. And get this, that disk of gas can get so hot and so bright it can actually outshine all the billions of stars in its galaxy combined. We've also directly detected the ripples in spacetime itself, gravitational waves, that come from two black holes smashing into each other. So no, you can't see the hole, but its shadow on the universe is impossible to miss.
This is probably the biggest myth of them all. This idea that black holes are just wandering through space like giant vacuum cleaners, sucking up everything in their path. That is just not how they work. They follow the exact same laws of gravity as everything else.
Their extreme, weird effects only kick in when you get incredibly close to them. Here's a fun thought experiment. If we could magically replace our sun with a black hole of the exact same mass, you know what would happen to Earth? Nothing. We wouldn't get sucked in. We would just keep orbiting it perfectly fine. Now, it would get very, very cold, obviously, but our orbit wouldn't change one bit.
And now, for the question that I know you've been waiting for. What would actually happen to you if you fell into a black hole? Well, for a smaller one, there's a very scientific, very strange word for your fate: spaghettification. Here's how it works. As you fall feet first towards the black hole, the gravitational pull on your feet is going to be way, way stronger than the pull on your head, just because your feet are a little bit closer. This huge difference in force would stretch you vertically while squishing you horizontally. It would literally stretch you out like a piece of spaghetti until you were torn apart, atom from atom. It's a truly bizarre and grim way to go, but it's a direct result of the most extreme gravity imaginable.
So as we've seen, black holes are so much more than just these empty voids. They're the final chapter for massive stars, they're the anchors for entire galaxies, and they're the ultimate testing ground for our most fundamental theories of reality. They represent the absolute limit of gravity, space, and time as we know it.
And that, of course, leaves us with the biggest question of all. From what's really happening inside the singularity, where our physics breaks down, to what role they play in the ultimate fate of the cosmos, black holes are still guarding some of the deepest secrets of our universe. The more we learn about them, the more we realize how much is still waiting to be discovered inside this ultimate enigma.